Assalamu alaikum. In this video, I'm going to show you how to solve the assignment problem which is unbalanced using the Hungarian method. Let's look at this assignment problem, right? Now we have three workers, so we have S, I, and Z. So we have three workers here, but we have four projects, A, B, C, D. Okay, so what we have to do is we have to add another worker which we call dummy, and this dummy has 0 costs. Now if we are short of project, okay, let's say we have 4 workers here and we only have 3 projects, then we have to add a dummy project with 0 cost, so the column will be 0. In this case, the rows will be 0. Okay, so the first thing to do is we are going to identify the minimum value for each row. Okay, so we can see that the minimum cost here is 10, and in this row the minimum cost is 8, and here the minimum cost is 9, and of course here the minimum cost is 0. Okay. Okay, so the next step is to take away the minimum value here, 10 for example, from all the values in the row. Okay, so we have 11 minus 10, which is 1, and then 12 minus 10 is 2, 10 minus 10 is 0, and 12 minus 10 is 2. And in the next row, minimum value is 8, so 10 minus 8 is 2, 12 minus 8 is 4, and 8 minus 8 is 0. And lastly, we have 9 minus 8 is 1. Alright, now for the third row, we have minimum number is 9, so 9 minus 9 is 0, 10 minus 9 is 1, 9 minus 9 is 0, and 11 minus 9 is 2. And for the dummy row, of course, it will become 0 because the minimum value is 0. Okay, now let's look at the column. For each column, we can see that the minimum value is 0, right? And you see third column and the fourth column. So for column reduction, the table will still be the same as this table. Okay, all right, so now we are ready to check whether this table is optimal or not. So what we are going to do is we are going to draw lines that cover the zeros in this table. Okay, so we can see that in this column we have 2 zeros, in this row we have 4 zeros, and then we have zeros here, and then we have zeros here. So we are going to draw the minimum number of lines that cover all the zeros. Okay, so let's try. It looks like we can draw one line here, okay, and then one line here, okay, and the last column will be this one, okay, and this is the minimum number of lines, which is 1, 2, 3 that we can draw that covers all the zeros in this table. All right. Okay, or we can change the way we draw the lines. We can also draw like this table. Okay, we can draw like this table if we want to, but it still be the same. The answers will be the same. Okay, we can draw like this. We can draw the line across here, all right, and then across here. Okay, it doesn't matter which one. Now, so we know that we can only draw 3 lines, 1, 2, 3, but the number of rows are 4. 1, 2, 3, 4, and the number of columns are 4. That means the number of lines the minimum number of lines that we can draw that cover all the zeros are less than the number of rows or the number of columns. So this table is not optimal yet. Okay, so how do we get an optimal table? Okay, now let's use this table. Now we have these numbers that are uncovered. Okay, now the minimum for these numbers that are uncovered is 1. Alright, 1. So what we're going to do is we are going to minus 1 from all these numbers, okay, that are uncovered by the lines. Now this number here will stay as it is. Same thing here, this number will stay as it is. Okay, and this number will stay as it is. Now the number at the junction will be added 1, the minimum value 1. So this will take the value of 1, and the same thing here, this is another number at the junction of these lines, okay, will be added 1. Okay, so that we have this table here. Okay, we will have this table here. You can see alright, so this value 1 is minus 1, so we get 0. 2 minus 1, we get 1. Now 0 stays the same, so 0. 2 minus 1, we get 1. And here 2 minus 1 again, we get 1. 4 minus 1, we get 3. Now 0 stay the same, and 1 minus 1, we get 0. Alright, now over this row, 0, 1 and 2 stay the same. So 0, 1 and 2 stay the same, but this 0 at the junction will be added 1, so we get 1. And again here we have 0, 0 stay the same, and this 0 at the junction will be added 1, and this 0 stay the same. Okay, so now we have this table here, and we can see that we can draw the minimum number of lines is 4. Okay, that cover all the zeros. You can see that 1 line, 2 lines, 3 lines, 4 lines, 5 lines. So this is 5. Okay, let's try and draw 4 lines. 1, 2, 3, 4. Okay, or 1, 2, 3, 4. So we can draw the minimum number of lines that cover all the zeros is 4. Okay, the number of lines is 4, and these lines will cover all the zeros. Okay, so this is the optimal table already. Alright, now we are going to assign, because this is already optimal. Now we can assign the jobs, the projects to the workers here. Alright, so how do we do that? Now let's look for a row or a column that has only 1 0. So it looks like column B here has 1 0. Okay, so we have column B, and this is the row that intersect. Okay, so we have one assignment here, that is dummy will be assigned to project B. And then the next row or column that have 1 0 is either this row or this column, right? Doesn't matter. So let's try and do this column. Okay, so we have, right, so an assignment here at the junction here. So that means I will be assigned project D. And then we have this row with 1 0. Okay, that means Z will be given project A. Okay, and finally this row has 1 0. Okay, so S will be assigned project C. Okay, so we have the result here. Okay, now you can see that S is assigned to C with a cost of 10. This is 10 here. So S is assigned to C. I is assigned to D. D has a cost of 9. Okay. And Z is assigned to A, which is with the cost of 9. And dummy is assigned to project B. And the total cost is 28. Okay. So that's it.